We are first going to start with section 1.1, which covers the distributive property. Now you should be following along in your write-in textbook on page 3. So right now you should all be on page 3, and I want you to look under the solve it problem, where it says write your solution to the solve it in the space below. You can either use the bar scanner or the QR code in the upper right-hand corner, or I will go ahead and write down the problem here. So here are the 4 examples. Now if you remember what the distributive property is, the distributive property is a way that you can actually simplify an expression by multiplying what's outside the parentheses to everything that's inside the parentheses. So let's look at the first example. We have 3 times the sum of 8 plus 5. So 3 times the sum of 8 and 5. We could do this 2 different ways. We could just take 8 plus 5 by order of operations, get 13, and take 3 times 13 and get 39. However, using the distributive property, you can take 3 times 8 plus 5. So we take 3 times 8 and 3 times 5. That gives us 24 plus 15, which also gives us an answer of 39. In that problem, either way is an acceptable way to write an answer. In number 2, we take 3 times the sum of x and 5. So if we took 3 times x, now you could write it like this, 3 times x plus 3 times 5, but you can just skip that step and do 3 times x, which is 3x, 3 times 5, which is 15. Therefore, my answer is 3x plus 15. Example number 3. We have a times the difference of b and c. So we could take a times b, and that would give us ab, and a times negative c, or a times minus c, and that gives us minus ac. So our expression would be ab minus ac. Example number 4. 3y times 2x and 3y times 4. 3y times 2x, well 3 times 2, that gives us 6. Y times x gives us xy, or yx, but we usually write these in alphabetical order. And 3, now remember, the coefficient of that y is 1. So we take 3 times 1, that gives us 3. And we take y times y. Well, y times y, think of it this way. If you took 5 times 5, that's 5 to the second power. If you took y times y, that's going to give you y to the second power. And my answer, since none of these are like terms, will be 6xy plus 3y squared. So all of that should be written in your solve it problem. I want you now to take a look at the shaded box in the middle of page 3. It says, to solve problems in mathematics, it is often useful to rewrite expressions in simpler forms. The distributive property, illustrated by the area model below, is one property of real numbers that helps you simplify expressions. So I want you to look at the box, what they did. They want you to find the area of the rectangle with a base of x plus 5 and a height of 8. Notice what they did. You have to take 8 times x plus 5. They, in the second diagram, cut the rectangle up into one piece as x and one piece as 5. And then it says this model shows that 8 times x plus 5 equals 8 times x plus 8 times 5, which would actually end up giving you 8x plus 40. So look at the property of distributive property below. So look at all those examples. I want you to look over them and make sure you understand what they did. So take a few seconds here, just look over the algebra and the examples of what they did. So now flip the page in your book to page 4. We're going to try the got it section at the top. So we're going to look at part A. We're just going to do these together. Take 5 times x plus 7. What would that give you? 5 times x, 5 times 7. 5 times x is 5x. 5 times 7 is 35. Our expression would be 5x plus 35. Example B. 12 times 3 would give us 36. 12 times 1, 6. Now some people are like, oh, I can't do fractions. Yeah, you can. This is really easy. 12 times the numerator, 12 times 1, that just gives us 12, divided by the bottom, so times the top, divided by the bottom. 12 times 1 is 12, divided by 6 is 2. So since we have a negative here, 12 times negative 1/6 would be negative 2t. So it would be 36 minus 2t. C, 3 times 0.4, 3 times 1.1c. 3 times 0.4, well 3 times 4 is 12, so 3 times 0.4 would be 1.2, plus 3 times 1.1c would be 3.3c, and that would be my answer. And remember, just because the 3 is at the end instead of the beginning, you can still distribute. It just means the same thing. Same thing here. We're going to distribute a negative y. So negative y times 2y, negative, remember there's a 1 here, so negative 1 times 2, that gives us negative 2. Y times y is y squared. And negative 1y times negative 1, well, a negative times a negative is a positive, and that'd just be 1y. These are not like terms because they're different exponents. Negative 2y squared plus y. I want you on your own to do number 1 and 2 under the practice A. Pause the video. So if you did it, practice A and number 1. Number 1 would give you f minus 2, or 1f minus 2. And number 2 would give you 12z plus 15. So now we're going to look at online problem number 2, where it says problem number 2. We're just going to start with the got it's. Before we do the got it's on this section, I want you to look at the little shaded region above it. It says a fraction bar may act as a grouping symbol. A fraction bar indicates division. That should be easy. Any fraction that's written as a divided by b can also be written as a times 1 over b. You can use this fact and the distributive property to rewrite some fractions as sums or differences. So I'm going to show you something. You can write this down or you can just pay attention. For example, if I gave you 5/6, you can rewrite that as 5 times 1/6, because 5 times 1 gives you 5/6. So what we're going to do is we are going to look at this 4x minus 16 divided by 3. All of it's divided by 3. Both of those terms are being divided by 3. So we actually can take the 1/3 out. And this is what it looks like. 1/3 times 4x minus 16. Now if you distributed that, 1/3 times 4 gives us 4/3 x. 1/3 times negative 16 gives me negative 16/3. That's my answer. You can't take 4 divided by 3 and 16 divided by 3 and get a nice neat number, so we can leave them as improper fractions. So let's look at this. All you have to do is we are taking this and rewriting it as a addition or subtraction problem. I took this and rewrote it as a subtraction problem. Look at what I have here though. We can do a shortcut. 4x divided by 3, which is just 4/3 x, minus 16 divided by 3, minus 16/3. Okay, let's look at the next one. 11 plus 3x divided by 6. What can we take out? The 1/6. If you take out the 1/6, you're going to be left with 11 plus 3x. Distribute the 1/6. 11/6 plus 3/6 x. Now, is that simplified? Absolutely not. So we have to simplify that, so that would give us an answer of 11/6 plus 1/2 x, because 3/6 simplifies into 1/2. So that would be my answer. Let's try the next one. Take out a 1/12. That gives us 15 plus 6x. Distribute the 1/12. That gives us 15/12 plus 6/12 x, or 6x over 12. Those can both be simplified, so let's think about it. What number goes into 15 and 12? It'd be 3. Divide by 3. So that would give us 5/4, I'm sorry, not x. 5/4 plus 1/2 x. And that would be your answer. Now let's look at the got it section on the middle of page 5. This part's easy. I'm only going to do 2 examples. Example number A is negative times a plus 5, and B is negative times negative x plus 31. So look at what it says there next to B. What does the negative sign in the front of the parentheses mean? Look back up top right above that where it says that little shaded box. It says the multiplication property of -1 states that if you have -1 times x, that gives you negative x. So basically all it means is that if you have a negative out front, it really means you're distributing a -1. So both of these problems, you're just distributing a -1. You can write it, you do not have to. So all you do, distribute that. -1 times a is -1a. -1 times 5 is -5. So in part A, it's -a minus 5. In part B, -1 times negative x would be x minus 31. That's it. You're done. We are now going to be on page 6, where it says, using the distributive property for mental math. Now, you've done distributive property before, so all of this so far should be very easy. But let's look at the got it problem where it says, Julia commutes to work on the train 4 times each week. A round trip costs $7.25 for a ticket. What is her weekly cost for tickets? Use mental math. Mental math. That means no calculator, do it in your head. Now, some of you are like, well, how is this difficult? This is really easy. All I'm doing is taking 4 times $7.25. But you're going to do that in your head. So here's how you're going to think about the got it problem. You are taking 4 times what? You're taking 4 times the $7, but also the 25 cents. So 4 times $7 gives you what? It'd be $28. 4 times 25 cents gives you $1. So really, this would be how much? It'd be $29 for her weekly cost of tickets. And I did that completely in my head. So let's look at, I want you to try practice A and practice 8 or 7 and 8 on your own. So on practice A, do number 7 and 8 on your own. Pause the video and then I'll tell you the answer. Number 7 would give you $4,725, and number 8 would give you 985 miles. And this last section is going to be the last thing we're going to learn today. You already know about like terms. Now, I want you just to follow along and read the essential understanding part at the bottom of page 6. I'll read it with you. You can simplify an algebraic expression by combining the parts of the expression that are alike. Now, this is called like terms. In an algebraic expression, a term is a number, a variable, or a product of the number and one or more variables. A constant is the term that has no variable. So a constant does not have a letter. A constant is just a number. A coefficient is a numerical factor of the term. So a coefficient is the number in front of the letter. So rewrite expressions and sums to identify these parts of expression. So look at the bottom where it says 6a squared minus 5ab plus 3b minus 12. The coefficients are 6, -5, and 3. Those are the numbers in front of the variables. Now if you notice the -12 at the end, the -12 is the constant. So look at the top of the next page. Look over it yourself. You can pause the video. Look over it. You can see what it says are terms and like terms and so on. All right, like terms. Now we're going to start with just an easy problem. You can just watch me. You've done this before, so this is nothing new. 3x plus 2x. Obviously, those are like terms. You cannot tell me they are like terms, though, because they have the same letter. Because now they're not like terms. Why would these not be like terms? Because the exponents, the powers, also have to be the same. So if we had, for example, three x plus 2x, that would give us 5x. Easy. If we have 3x plus 2x squared, that's your answer, because they are not like terms. They have to have the same combination of letters and exponents. So look at the got it problems on the bottom of page 7. So let's look at A. Really easy. 3y minus y. So let's look at this one more time. I want to make sure you understand what these vocab words mean. 3, what would you call 3? 3 is the coefficient. What is the coefficient of this y? What number is right here? It'd be a 1, so that's a negative 1. So all this is 3y minus 1y, which will give us 2y. B, negative 7m n to the fourth minus 5mn to the fourth. Notice that the m n to the fourth and m n to the fourth are exactly the same. So everything is exactly the same. So you just combine the negative 7 and negative 5. Negative 7 and negative 5 is negative 12. M n to the fourth. And that's it. You're done. C. 7y to the third z minus 6yz to the third plus y to the third z. We have 3 terms here. Do all 3 terms have the same combination of variables with powers? No. But if you look, this one right here has a y to the third z. This one right here has a y to the third z. So all we do is combine them. 7 plus the 1, that gives us 8 y to the third z. And then the minus 6 yz to the third just comes straight down. And that's my answer, because these two do not have the same letters. These are not like terms. These 2 terms right here are not like terms. And the last thing I want you to do is do D on your own. Can you simplify that? Pause the video. So it says, can you simplify 8x squared minus 2x to the fourth minus 2x plus 2 plus xy further? The answer is no. It is already simplified since there are no like terms to combine. None of the letters have the same exponents on them, so there are no like terms at all. So in review, you learned about the distributive property. You learned about using the distributive property of fractions, mental math, and like terms.